Evaluate the limit at x go to pi of x squared times cosine of x. This is the product, and derivative at x go to pi of x squared exists. Derivative at x go to pi of cosine of x exists. So we can use the product rule of the limit, which state that the limit of a product is the product of the limit. We take the limit of each of the factor and we multiply them. The limit of the first factor times the limit of the second factor. At x go to pi, x squared go to pi squared. And at x go to pi, cosine of x goes to cosine of pi. But cosine of pi is -1, so this limit is -pi squared. Evaluate the limit at x go to infinity of x to the fifth times 1 minus 1 over x. This is again a product. The limit at x go to infinity of x to the fifth does not exist, but it increases without bound, so it doesn't exist in a special way. It's go to infinity. The limit at x go to infinity of 1 minus 1 over x is the limit of the difference, whose limit of the second term is 1 over a very large number, which is a very small number. So this limit is 1. Technically, we cannot use the product rule of the limits, but if we have a very large number, multiply 1, which will end up a very large number. And so this limit doesn't exist, but it doesn't exist in a special way. We know that at x go to infinity, the entire expressions go to infinity. Evaluate the limit at x go to infinity of x times e to the x. This is still a product. At x go to infinity, the limit of the first factor go to infinity. X gets large, x gets large. And as x go to infinity, e to the x is getting very large. E raised to a very large number is a very large number. And again, similar to the previous case, we cannot use the product rule of the limits, but this is a very large number times a very large number. We expect that the product of the two very large numbers is still very large. So that limit doesn't exist, but it doesn't exist in a special way.